Welcome back. This is Mr. Tipton, and today we are talking about measures of variability. MOV, that's how I abbreviated, describe the distribution of data, which, variability comes from the word varies. It's how spread out the data is. Our first measure of variability you've probably heard of, the range. The range is just the difference between the greatest and the least values of a data set. Something that is probably new to you are, they're called quartiles. Quartiles are values in your data that divide your data into 4 equal parts. Okay, there's something called an interquartile range, which, quartiles, interquartile and range, we know. The IQR, the range of the middle half of a set of data. It's the difference between the third and the first quartiles. That doesn't mean anything to you yet, but it's actually really easy. I'm going to show you how to do it now. If you can find the median of a set of data, you can do this. All right. So here we're told to find the range and the interquartile range of these U.S. Summer Olympic silver medals from 1976 to 2008. All right. Well, first thing, range. We know our greatest value here is 61 minus our smallest value, which is 0. So our data here has a range of 61. Okay, no big deal. Now let's talk about the interquartile range. First, we're going to have to find the median. So we need to put these numbers in order from least to greatest. And we have 0, 24, 31, 32, 34, 35, 38, 39, and 61. 61's a lot higher than 39, and actually 0 is a lot lower than 24. So we've got some outliers here. Median is good when there's outliers. The median, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So this right here is our median. It's right in the middle. This is actually it's actually our second quartile. It's the middle of the entire set of data. The second quartile is 34. Now, so the medians, it also, besides being the middle number, it also splits the rest of the data. You've got the lower half and you've got the upper half. All right? So the first quartile, and I'm just going to write Q, it's the median of all the data that's below the median. Okay, so the median of the whole set is 34. The median of the lower half is our first quartile. It's what would go right here because we've got 4 numbers. 24 and 31 gives us 55, and if we divided that by 2, we get 27. So our first quartile is 27. Okay, that goes right here. Okay, same thing for the third quartile. It's going to be the median of the upper half. The upper half. 34 divides it in half. The lower half, the upper half. 34 is right in the middle. So the median of the upper half, what's right in between 38 and 39? 38 and a half. Okay, our third quartile is 38 and a half. So now, what's our interquartile range? Remember from the other screen, it's the third quartile. Where am I going to write this? I'll write this down here. It's the third quartile minus the first quartile. So 38.5, that's a really ugly 8, isn't it? 38.5 minus 27 is 11 and a half. This is the interquartile range. It is the middle, it's the range of the middle half of our data. All right. What we're going to do next is probably going to make it easier to see how the quartiles break up data into 4 parts. And we're going to do something that's called, we're going to make a box and whisker plot. Box and whisker plot. Feel free to pause it and write stuff down before you get going. This table right here is the same one that was on the page before. Here are the values that we just found. The first quartile is 27. Second quartile, which is the median of the whole thing, is 34. And the third quartile is 38.5. Now, I've also added a couple of other things. The lower extreme, you can probably figure out, is the lowest number in all our data. We've got that 0 right there. That's our lower extreme. The upper extreme is our greatest value in our data. That's where those came from. These 5 numbers help us make a box and whisker plot. Okay? Lower extreme is at 0, so we put a dot above 0. The upper extreme is at 61, so we'll put a dot up here at 61. First quartile is at 27, so that's 25 right there, so 27 is going to be right there-ish. Third quartile is 38.5, so getting pretty close to 40. And did I forget something? Oh, the second quartile. Whoops. Second quartile is at 34, which is right there. Okay? These 5 points allow us to make a box and whisker plot. Well, we need a box and we need whiskers. The box goes around the interquartile range. The interquartile range is the range of the middle half of the data. And then our whiskers, we get whiskers drawn from the box to both the lower and upper extremes. And then we're going to go ahead and draw a line through our median, our second quartile as well. So hopefully now you can see that this whisker right here, that is 1/4 of the data. Okay, from this here to here, that's another 1/4 of the data. From here to here is another 1/4. And then from the box to the upper extreme, that's another 1/4 of our data. Okay, so that's a visual representation of the quartiles. It splits the data into four parts, and the longer those whiskers are, the more spread out the data is. And just one more time, the box, all this right here, that is our interquartile range. It's the range of the middle half, and that's a half. Even though it looks smaller, there are more numbers in a smaller area. Remember, because that 61 and the 0, those are outliers. So it made the whiskers go out longer than the box appears to be. Let's do one more. We're going to start out by finding the range and interquartile range of Marley's paper airplane tosses. Start with the range. Our highest number of feet here is 53, minus our lowest number is 25, so our range is 28 feet. Now the interquartile range, need to order the numbers from least to greatest, and we know our lowest is 25. We also have 38, 39, 40, 44, 45, 49, and 53. Okay? So let's find our quartiles. There are 8 numbers, so our median, our second quartile, would go right in between 40 and 44. So our second quartile, Q2 or 2Q, whatever, is going to be 42. Okay? That number splits us into a lower half and upper half. So the median of the lower half would go right here. Our first quartile is 38.5, right in between 38 and 39. And our third quartile, what's right in between 45 and 49? That is 47. Okay, so these are the 3 numbers that split our data into 4 parts. All right, on the next screen, we're going to make a box. And then we'll have whiskers going out to our upper extreme and our lower extreme. Gosh, that's almost a box and whisker plot right there. Kind of ugly though. Let's clean it up. Oh, what did I forget? I forgot to find the interquartile range. Whoops. Third quartile, 47, minus the first quartile, which is 38.5. And what's that give us? Interquartile range is 8.5. 8.5 feet for the airplane tosses. And that means half of the data, the middle half of the data, only has a range of 8.5 feet. Alright, box and whisker plot. Need a dot for our lower extreme, 25. Dot for the upper extreme on 53. We need a dot for 38.5. A dot for 42. That's the median of the whole thing, and another dot for 47. We put a box around our interquartile range, and we draw whiskers out to our extremes. Alright, so that's a box and whisker plot. That's range, interquartile range, quartiles. If it's confusing, watch it again, write down some questions, and we'll talk about them in class. See you soon.